Good morning everyone. So first let us start with module 2. Actually module 1 it is all about RCC and module 2 it is about steel, structural steel, design of structural steel. So in that first part is your roof truss. Okay. In this roof truss we'll get to know the components. So bottom whatever it is there, so I'll name this as A and this is B and this is your C. Okay, so this bottom line we call it as a bottom chord member, and this top line we call it as a top chord member, and inner side inside whatever it is there, this we call it as an inner chord member, and this part we call it a gusset plate. This gusset plate thickness should be a uniform thickness, and this thickness should be 8 mm, 10 mm or 12 mm. Whereas while selecting an angle for the bottom chord member and as well as to a top chord member, you need to select double angle. Okay, and minimum angle should be 50 by 50 by 6. Okay, so maximum of that you can select it, but minimum ಅದಕ್ಕಿಂತ ಕಡಿಮೆ angles ನ select ಮಾಡಬಾರ್ದು. Whereas for the inner chord member, you need to select a single angle. Okay, so whereas for the double angle you will select your 2 ISA, so that is 2 ISA will select it, but whereas for the inner inside, that is nothing but your inner chord member, for inner chord member you will select as 50 by 50 by 6, that is standard minimum you should select that. Okay, so now let us know what is that important point. So the same important points, that is select double angle for top chord and bottom chord. Okay, I mean for this part and for this part you need to select a double angle, whereas second point is select single angle for inner chord member. This part is your inner chord member, for this you need to select single angle. Next, third point is provide minimum of 2 bolts for the connection in bolted roof truss. Okay, these connections are there now for the top, connecting your inner chord member and top chord member, and use a gusset plate. When you use a gusset plate you can do a two types of connections, because in the basic steel you might have studied that two types of connection, one is bolted connection and other one is welded connection. In case if they ask in a bolted connection, what you have to do, you need to select minimum number of bolts should be 2 number of bolts should be there, you are not supposed to use 1 number of bolts. Okay, coming to this fourth point, this what does your fourth point is, take effective length, that is LE. Okay, L suffix E equals 0.85 times of L, 0.85 times of L. Next, the fifth point is provide uniform thickness of gusset plate, provide uniform thickness of gusset plate, in the sense 8 mm, 10 mm, 12 mm, 14 mm, 16 mm. See, in that way you need to provide a thickness for the gusset plate. So next, the last point, that is sixth point, is minimum size of angle. As I said earlier, the minimum while selecting an angle, minimum size it should be 50 by 50 by 6 mm. Okay, ಇದಕ್ಕಿಂತ ಕಡಿಮೆ ಇರೋಂಥ ಆ್ಯಂಗಲ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಬಾರ್ದು. ಓಕೆನಾ, so here two types of problem will be having. Okay, design one is type 1. First let us deal with type 1. In this type 1, what all you need to calculate? So one is outer maximum compression member, outer maximum tension member, inner maximum compression member, inner maximum tension member. Okay, as I said, do not select angle less than or smaller than ISA. ISA, it is nothing but Indian standard angle, 50 by 50 by 6 mm. Okay, come, let us know about type 1 problem. What is the problem says? The central line diagram of a steel truss is shown in the figure. The magnitude and nature of forces in different members of the truss are given in table. The size of the RC column supporting the truss is 300 mm by 300 mm. Use M20 concrete for column. Design the truss using bolted or welded connections. Okay, this connection, it is left to you, it is up to you, what any connections you can do, either you can choose a bolted also, or you can choose a welded connection also. And also design anchor bolts for an uplift force of 15 kilonewton at each support. Draw to a suitable scale, take reaction as 50 kilonewton. Okay, and they have asked you for these three diagrams also. One is, first one, elevation of truss greater than half span. Okay, and second one, enlarged view of apex joint of the truss, and third point is enlarged view of the left support joint. Okay, come, let us know what all the data has been given in the question. So one is what they have given, magnitude and nature of the force. The different members of the truss are given in the table. In the table they have provided. Where is that table? Table is here. Okay, this is your table. So, and what else they have asked? The size of the RC column supporting the truss, because truss stands on the column, right? So truss, it is standing on the RC column. The RC column size is 300 mm by 300 mm, they are saying. And FCK, that is grade of the concrete, it is M20 for the column, and design the truss using bolted or welded connection, and they have given a force also. This anchor bolt, it is required to connect your truss and column. Okay, connect your truss and column, you need an anchor bolt. Uplift force of 15 kilonewton at each support they are asking, and draw to a suitable scale, take reaction as 50 kilonewton. So look at here, this is your truss. In this, A and B is A, F, G, B is bottom chord member, A, C, D, it is your top chord member, and the same way D, E, B is your top chord member, whereas C, F and FD, DG and GE is inner chord member, and the span of the truss at the each this thing is 4 meter, 4 meter and 4 meter. So come let us know. Let's see the table. What they have given the table. So first column is member, second column is force, and third column is length. Okay. In this AC comma EB. Okay. Force what they have given, minus 80 they have given, and the length also they have given, that is 3.46 meter. Okay. What is this AC and EB? Whether it is in a top chord member, or whether it's a bottom chord member, or it is in a inner chord member. So let us see, where is AC? AC, it means top chord member. AC comma CD. Why they have given? One side they have given. AC comma EB. I mean, what does it mean? AC, this part is AC and this is EB, other side. Okay, one side is AC and other side it is EB, it is there. Okay, whereas coming to this CD, AC is also compression member and EB is also compression member. How am I saying that it is a compression member? Because these values are negative values. When the force is in a negative, so that we take it as compression member, that we consider it as compression member. Okay, coming to this CD and D. CD is this part. This part is CD and this part is D. Okay, so it means these two are top chord members. In that also force is minus 70 kilonewton is there. So that is, and also length of the span, how much they have given, 3.46 meter. It means it is understood when the negative values comes, negative force comes, it means the truss, it is subjected to compression member, the member which is subjected to compression force, compressive force. Okay, in the previous class I told that truss, it is subjected to two types of force. One is compressive force and second one is tensile force. Whereas coming to this AF and GB. Okay, what is this AF and GB? That is now in the drawing. Let's see in the drawing. AF, this part, it means bottom chord member, and this part, it is GB, it is also a bottom chord member. So AF and GB is 70 kilonewton, length is 4 meter, and FG is 50 kilonewton and the length is 4 meter. It means these two are bottom chord member, and also the values, the force, it is in a positive. Okay, positive forces. So it means these two, I mean bottom, you need to do a design for the bottom member as tension member. Tension design ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆನಾ, ಟೆನ್ಷನ್ ಡಿಸೈನ್ ಏನು ಪ್ರೊಸೀಜರ್ ಇದೆ, ಟೆನ್ಷನ್ ಮೆಂಬರ್ ಡಿಸೈನ್ ಪ್ರೊಸೀಜರ್ ಮಾಡಲಿಕ್ಕೆ ಏನು ಯೂಸ್ ಮಾಡ್ತೀರಿ ಅದನ್ನು ಮಾಡ್ತಾ ಹೋಗಬೇಕಾಗುತ್ತೆ. ವೆರಾಸ್ ಫಾರ್ ದಿಸ್ top chord member, it is subjected to a compressive force. It means the force which is showing in the table, it is negative. So it means the member is negative. It means the member is subjected to a compressive force. ಸೊ ಹಾಗಾಗಿ ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್ದು ಏನು ಡಿಸೈನ್ ಇರುತ್ತೆ ಆ ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್ ಡಿಸೈನ್ ಪ್ರೊಸೀಜರ್ನ ಫಾಲೋ ಮಾಡಿಕೊಂಡು ಈ ಮೆಂಬರ್ಸ್ನ ಡಿಸೈನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ವೆರಾಸ್ ಫಾರ್ ದೀಸ್ ಪಾಸಿಟಿವ್ ದಿಸ್ ಥಿಂಗ್ ಫಾರ್ ಯು ನೀಡ್ ಟು ಡೂ ದಿಸ್ ಆಸ್ ಎನ್ ಅ ಟೆನ್ಷನ್ member. Okay, and also while taking in a force, you will select a force, okay, out of these two any one force you will select it. So which force do you select it, which one is the maximum value, okay na, andre compressive force design ಮಾಡುವಾಗ force value ನ ತಗೊಳ್ತೀರಿ. ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಳುವಾಗ ಯಾವ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಬೇಕಾಗುತ್ತೆ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು ಅಂದರೆ ಈ ಎರಡೂ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಯಾವುದು ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇದೆ ಆ ವ್ಯಾಲ್ಯೂನ ನೀವು ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ಕಮಿಂಗ್ ಟು ದಿಸ್ ಬಾಟಮ್ ಕಾರ್ಡ್ ಮೆಂಬರಲ್ಲಿ, ಬಾಟಮ್ ಕಾರ್ಡ್ ಮೆಂಬರಲ್ಲಿ ಒಂದು 70 ಇದೆ, ಇನ್ನೊಂದು ಸೈಡ್ 50 ಇದೆ. ಓಕೆನಾ, ಇವು ಎರಡರಲ್ಲೂ ಸೊ ಪಾಸಿಟಿವ್ ಪ್ಲಸ್ ಅಂತ ಬಂದಾಗ ಆಬ್ವಿಯಸ್ಲಿ ಇಟ್ ಇಸ್ ಸಬ್ಜೆಕ್ಟೆಡ್ ಟು ಟೆನ್ಷನ್ ಫೋರ್ಸ್. ಸೊ ನೀವೇನು ಮಾಡ್ತೀರಿ, ಟೆನ್ಷನ್ ಮೆಂಬರ್ ಥರ ಡಿಸೈನ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತೀರಿ. ಸೊ ಟೆನ್ಷನ್ ಮೆಂಬರ್ ಥರ ಡಿಸೈನ್ ಮಾಡ್ಕೊಂಡು ಹೋಗುವಾಗ ಫೋರ್ಸ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಯಾವ ಫೋರ್ಸ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ, ವಿಚ್ ಒನ್ ಇಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಮಾಂಗ್ ದೀಸ್ ಟು. ಸೊ ಆ ಫೋರ್ಸ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ, ಅಂದರೆ 70 ಕಿಲೋನ್ಯೂಟನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ ಯಾವಾಗ ಟೆನ್ಷನ್ ಮೆಂಬರ್ ಡಿಸೈನ್ ಮಾಡಲಿಕ್ಕೆ. ವೆರಾಸ್ ಕಂಪ್ರೆಷನ್ ಮೆಂಬರ್ ಡಿಸೈನ್ ಮಾಡಲಿಕ್ಕೆ 80 ಕಿಲೋನ್ಯೂಟನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀರಿ. ಓಕೆನಾ. ಸೊ ಕಮಿಂಗ್ ಟು ದಿಸ್ ಸಿ ಎಫ್ ಇ ಜಿ ಆ್ಯಂಡ್ ಡಿ ಎಫ್ ಅಲ್ವಾ. ಸೊ ವೆರ್ ಇಸ್ ಸಿ ಎಫ್ ಎಲ್ಲಿದೆ, ಸೊ ಸಿ ಎಫ್ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಯುವರ್ ಇನ್ನರ್ ಕಾರ್ಡ್ ಮೆಂಬರ್. ಆಯಿತಾ, ಸಿ ಎಫ್ ಆ್ಯಂಡ್ ಏನಂತ ಕೇಳಿದರು, ಇ ಜಿ. ಓಕೆ, ಸಿ ಎಫ್ ಆ್ಯಂಡ್ ಇ ಜಿ. ಇ ಜಿ ಎಲ್ಲಿದೆ, ದಿಸ್ ಈಸ್ ಯುವರ್ ಪಾರ್ಟ್, ದಿಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ದಿಸ್ ಪಾರ್ಟ್. ಓಕೆನಾ. ಸೊ ಸಿ ಎಫ್ ಆ್ಯಂಡ್ ಇ ಜಿ ಈಸ್ ವಾಟ್ ದೇ ವಾಸ್ -24 ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಆ್ಯಂಡ್ ದ ಲೆಂತ್ ಈಸ್ ಹೌ ಮಚ್ 2 ಮೀಟರ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ವೆರಾಸ್ ಡಿ ಎಫ್ ಅಂತ ಬಂದಾಗ, ಡಿ ಎಫ್ ಅಂತ ಬಂದಾಗ ಏನು ಕೇಳಿದ್ದಾರೆ ಅವರು, ಪಾಸಿಟಿವ್ ಅಂದರೆ ಟೆನ್ಷನ್ ಫೋರ್ಸ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಲ್ಲಿ ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಿದೆ, ಇಲ್ಲಿ ಟೆನ್ಷನ್ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಅಂದರೆ ಸ್ಪ್ಯಾನ್ ಎಷ್ಟಿದೆ, 4 ಮೀಟರ್ ಇದೆ. ಇಲ್ಲಿ ನೀವೇನು ಮಾಡಬೇಕಾಗತ್ತೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಲ್ಲಿ ಎರಡೂ ಈಕ್ವಲ್ ಇರೋದ್ರಿಂದ ಐದರ್ ಯು ಕ್ಯಾನ್ ಡಿಸೈನ್ ದಟ್ ಎಸ್ ಅ ಕಂಪ್ರೆಷನ್ ಮೆಂಬರ್ ಥರ ಡಿಸೈನ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೋದು. ಇಟ್ ಈಸ್ ಲೆಫ್ಟ್ ಟು ಯು, ದೆರ್ ಇಸ್ ನೋ ಕಂಡೀಷನ್ ನೀವು ಕಂಪ್ರೆಷನ್ ಫೋರ್ಸ್ನೇ ಹಾಗೆ ಡಿಸೈನ್ ಮಾಡಬೇಕು ಅಥವಾ ಟೆನ್ಷನ್ ಮೆಂಬರ್ ಥರನೇ ಡಿಸೈನ್ ಮಾಡಬೇಕು ಅಂತ ಏನೂ ಇಲ್ಲ. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದಿಸ್ +24 ಆ್ಯಂಡ್ ಯು ಕ್ಯಾನ್ ಡೂ ಆನ್ ಅ ಡಿಸೈನ್ as a tension member. Either you can take -24 and you can start a design doing in a compression member. Okay, so coming to this solution. So step 1, what does the step 1 says, design of top chord member. Okay, so which is a top chord member, member is which are the what are the members are a top chord member. So these members are top chord member. I mean this AC is equal to, will take a half part of it. Okay na, we'll do a design for half part. So that time it is equal to other equal part also, no, other part also, no, other side also it is equal. So for that purpose what we say, AC. Okay, AC it is equal to EB. Okay, got it. And whereas coming to the CD, CD it is equal to DE. Okay, so now which are the top chord member now. So AC and CD are top chord member. AC, okay, AC and CD are top chord member. So it means AC is equal to EB and CD is also equal to DE. Is it not? So now, so member AC is 80 kilonewton. So where it is 80? Here. Okay, and they have neglected that symbol because sign conventions they have neglected. Whereas and coming to this member CD, it is 70 kilonewton and the length is both the side it is 3.46 meter, 3.46 meter. Maximum force is out of which one is the maximum, as I said earlier, 80 kilonewton. Ultimate maximum force, so multiply with your factor of safety, that is 1.5. So you will get your value as 120 kilonewton. So maximum force is 120 and maximum length is 3.46 meter. As I said earlier, the sign convention was negative. So it means you need to do a design as top chord member as a compression member using double angle, because I told you in the earlier class, that is for while selecting an angle for the bottom chord and as well as to a top chord member, you need to select in a double angle. And here I am doing in a bolted connections. Okay, for this step 1, okay, we'll start with the next class, step 1. Till this please understand this.